Okay, welcome to this video. In this video, I'm going to demonstrate how to perform data processing and data analysis for the History of Kazakhstan pilot UNT test. So let's start with the first few lines. First of all, we're setting our working directory to where our data is. So we need to run that. Of course, we should clear our working directory, our global environment, we should clear up here. Now the packages needed, there are several of them, so let's load them automatically. Now the raw data is comprised of raw scores, like letter scores, and keys down the bottom. You can see on the tab down the bottom here, you can see the answer keys. Okay. So we should read in the data test and the data keys. This can take a while. It can take that long. So now let's move to renaming those columns and that data and storing the data automatically. Now to do that, we need to run all the way to line 90. So this will generate dichotomous item response matrices for these tests, and you will see the outcome will be 0 or 1. So if we look at DF scores, we can see we have all the data and the outcomes are 0 or 1 down here. Okay. Let's move on to second parameters. We want to identify extremely easy and extremely difficult test questions. To do this, we use a constant. If we use a big constant like 1, this is going to only identify very, very extremely difficult and extremely easy test questions. But in this case, I'm using a smaller constant, so it's more sensitive. The constant is 0.5. You can define sort of like the grade or classification for the test. This is UNT March 2024, which was a type of pilot. Now, in this case, I'm defining a minimum sample as 200, but you might have to change that later if you don't have much data for your pilot study. The columns to score, this is the 6th to the 25th here. Dichotomous columns, there are 1 to 20 of them here. The item columns for this matrix happen to be from the 7th to the 26th. The subject in this case, we can change this each time, but in this case, it's History of Kazakhstan and the language is Kazakh. Now, this here is hashed out because we don't need it for this test. It's only for other tests like biology when they have non-dichotomous items. So let's run this here, and these are the parameters for this analysis. Parameters are all here. So we need to subset only History of Kazakhstan and the Kazakh language variants. So we run that here. Now, in that data, there's a lot of NAs here. So we need to remove those and only take the first 25 columns. So we run the next line here. Now with this code, we're trying to find out how many variants or forms, test forms, have more than 200. So we can check. We can see, okay, down here, variant 460 has 723 respondents. variant 461 has 764. So all of these have more than 200, which is like a type of minimum. Okay, so we can proceed and create a new data frame just for our test and subject of interest. Here, we're making a parallel unscored matrix, because with the DF at the moment is the scored matrix of the zeros and ones, but we also want to make a parallel unscored matrix with ABCDs as elements. So we run this code here to generate that. And this will generate the unscored matrix, which is like this. Here we're running classical test theory. Here we're generating our classical test theory outputs. Next, we continue with our classical test theory outputs, accounting for potential problems. For example, there may be all incorrect or all correct answers in the matrix, so we can account for this carefully with code, which I've done. Next, we do our rash analysis, which involves that constant of 0.5. You can see the constant here. This generates flags for too easy, which is 1 asterisk, and too difficult, which is 2 asterisks. Distractor analysis, this is a special type of analysis based on distractors. Distractors are the letters that are incorrect. So if you do a test and it's multiple choice and the correct answer is C, the distractors are A, B, and D. So we can run that analysis just to generate the proportions of A's, B's, C's, and D's for each test question. Next, we're running biserial correlations for each test question. For example, the correlation between question 1, A, response, and the total score in the test, and question 1, B, response, and the total score in the test, C, and total score, and D, and total score. So there's 4 forms of distractor analysis for each question. So we run all that. So the last one is for the D's. Okay. Next, we get the mean total score for each letter. So if I selected C for question 5, then what's the average total score for people that selected C for question 5? This gives us some more information. Next, we generate frequency of responses. This is basically how many people scored 0, how many people scored 1 for each question. At this point, we collate all results into a data frame. Now, let's look at what that data frame looks like. There it is. So you can see here, this is history of Kazakhstan. It has 20 questions. It's just one variant. You can see that this variant is test form 460. And these are the 20 items for that test form 460. This is the keys. This is the probability correct. That's the number of students that took the variant. And you can see all the other outputs here, all the way to the average score for those people who selected that D, average total score. Okay, So that's simply one variant. However, we should also do the other variants. Remember, there are 5, I believe. Now, so we have to run this same code here, but we're adjusting this number. This number is the second variant that has above 200, or 200 and above. So we run that code, and then we proceed to do the same analysis for that variant. And let's just jump through and do all 5 variants down to line 1122. So now that we've done analysis on all variants, we should find all results from the 5 variants as well. We can also get some output information. Let's run that. So DF all is results for all variants. We can also get some aggregate outputs here as well. And we also need to create an output document here as well, which involves the subject and the language. This is for our output results. So it's all prepared to create an output. Now the output is automatically generated, and each cell is color-coded depending on the result. We can talk about that later, but you simply need to run this code all the way to the end, and this will produce an output file called History of Kazakhstan here, which involves, which is the pilot test, which involves 3,680 total students, 100 total unique questions, and you have all the results there in that file. And here are all the results. This is the output file here. We can see that there's one item which has a negative point by serial, so that's a problem. It correlates negatively with the total. We can see some other flags here, like, for example, the proportions of A's for this question are quite low. So only 3% of the respondents selected A. So maybe it's not a very good distractor. If it's under 5%, it gets flagged red. Okay, now let's move to the other outputs here. There's also flags. Now let me just review. So a correct response option that is not related enough to a construct is flagged red. So this is a correct response option. C is the correct response option for this question here. Okay. C is the correct response option for that question. However, it doesn't correlate high enough. It's not above, it's not 0.3 or above correlation. So it's flagged red. Same here. Now the pink highlights, these are the incorrect distractors that are too connected to the construct. So these incorrect distractors, they should be negative, well, if they're greater than negative 0.10, then that's a problem. So these are greater than negative 0.10. So these are also flagged because it's as if they're too connected to the construct of interest. Anyway, so these are all the outputs, and this is just one test language combination, which is History of Kazakh variant. And there are 5 different forms for that test. Okay, so I hope that helps. Thank you very much. Bye-bye.